Parvati, like I told you, over phone, not over phone, over WhatsApp rather, that I've been studying, like I've been meaning to start this for a while. Um,
Okay.
Talking about different uh, research that is happening in different fields in climate science. And if you look at, there are so many like good podcasters uh,
Yeah.
that look very posh, but
Yeah.
they don't talk about like climate and related things.
Yeah.
Mostly they tactfully avoid those because there are not many, so it's always good to do something at least.
Yeah.
And
Of course.
talking about science rather, we
Yeah.
would tend to talk more about science and be
Mm-hmm.
more objective. And there is no target audience. We can say we are just doing it for ourselves and putting it out
Okay.
there and without much expectations. It's like
Yeah.
when you talk about different things, you also feel good. It's more like
Mm.
this, very
Yeah.
casual. You do not have to
Yeah.
prepare anything. And
Yeah. That's good.
I, I've been writing to quite a few scientists.
Okay.
Um, Firstly, I wanted to start with within the friend circle. So
Okay.
you are, uh,
That's a good
yeah,
start.
yeah.
Yeah.
So, uh, for the viewers,
Mm-hmm.
what kind of climate scientist are you? If you like explain yourself, because you worked on a variety of topics over the year from your PhD till now.
Yeah. So I'm basically a physical oceanographer. I have physics background, and in my bachelor's degree and in my master's degree, I did oceanography as specialized part, and then I started my PhD. So during my PhD research, I mostly looked at the physical oceanography part. So in India, we have this National Oceanography laboratories, for example, under the CSIR. So these are really focusing on the oceanography research, and we have divisions looking at physics, chemistry, and biology, and also some interdisciplinary aspects. So when I started right after my master's, so it actually starts along with my master's. So last semester in our master's is a dissertation. So master's project, we have to go to any national labs and do something with the scientists. So this is giving us hands-on training on the research and also like a hint of how it works basically. So I started with a physical oceanographer, obviously, and I worked for my proposed whatever time it was around 6 months, and I completed a project and I went back. So I already got how different it was from the classroom studies
Mhm.
versus the research. And then I really got interested in this because once you are actually studying the textbook, you never know how the actual research feels like. So then I went back. I again started working on the physical oceanography problems, like looking at the ocean water mass properties, for example. So, water mass is something which really distinguishes the ocean water. So, each water mass has certain characteristics in terms of temperature and salinity. So, for
Mhm.
example, we have these global oceans which are connected at some point in the globe. But say like the Indian Ocean water mass or a parcel of water, for example, it moves from Indian Ocean to Atlantic Ocean or Pacific Ocean. So it
Mhm.
retains its property of temperature and salinity. So that's like its identity. So we
Mhm.
can track them. It doesn't instantly mix with its ambient water and change its properties. So
Mhm.
temperature and salinity are retained and we can observe and track them. Okay, so this even if I take an observation from the Atlantic Ocean somewhere with its temperature and salinity, I can track it back, or I can say this is coming from the Indian Ocean or this is coming from the Pacific Ocean. So I
Mhm.
started with that. That was my first project. I used Argo data. So Argo is an instrument. So it's an autonomous instrument which collects the temperature and salinity from the surface to the deeper layers. So
Okay.
we looked at the temperature and salinity and tried to identify the properties of water mass. And then, but I was not quite sure I want to do PhD in that. It was not really something I can translate into the society. So that's what I thought at that young age. So I wanted some science, which whatever I do, I should be able to bring some message which can really help the society, for example,
Mm-hmm.
or policymakers, whatever way the message can be conveyed. Because we publish research papers which may not be easy for a non-scientist to read and understand. So we
Yeah.
have to really convey the message to the public, right? So
Yeah. And
so
sometimes, like when you're conveying the message, many of the scientists who get involved in the discussion, they would go too technical so that the
yeah,
listeners would get
yeah,
uh,
yeah,
a little distant from the
yeah,
discussion.
yeah,
And
exactly. Yeah.
how do you feel like the gap is now? Is it growing or is it kind of merging?
Oh yeah, so the gap maybe is getting a little bit narrower, I would say, because of the podcast, for example, or blog post. So people put an effort. Say, for example, you publish a paper. So that's
Mm,
too technical, but you can start a blog post, which is like in the proper language, which anyone without any expert can read and understand,
mm,
right? So I think the gap is getting narrower compared to 10 years back or even before. And also because of the visible impact of whatever climate change we are talking about, people are also more curious. So there are two aspects which is making the gap narrower as far as I believe. So
mm,
say like there is nothing affecting a normal life, people won't be bothered, right? What is happening in the
mm,
ocean, why we are doing the research, why we are publishing, doesn't matter. Now, even in school textbooks, say like an upper primary school textbook in India, they talk about El Nino, which was
mm.
not the case when I studied few years
Yeah,
ago, right?
I remember
So,
I get to know those terms much, much later in my
yeah,
academic career.
yeah, so it's really nice. It's really good. And they talk about pollution, several things. So these are like looking at the same problem from different angles, basically. So everything is interlinked. So it's much easier to get a flavor of all these things at young age. And
Mm,
I think the students are getting exposed more. So in turn, the teachers. So this just goes on, right? Once you learn something, you come
mm.
home and you discuss with your parents, or something is there like this. And I think that's really good.
Yes, definitely that is good. But at the same time, when we are learning, we are also
Hmm.
tend to normalize things
Yeah,
because that is something when we understand or we gather some information and do not process it. Gathering
yeah,
information and realizing it's two different things.
yeah,
Uh, uh, Gathering information is something that you can retrieve only in if the same context is available.
yeah,
Whereas when you're understanding things, you can actually use those information in different other contexts. And that is
yeah,
something our youth or like in the
yeah,
people as whole is lacking. Many of
yeah,
them like all those competitive exam, they have all those things,
yeah,
but people do not understand what it actually means.
yeah.
And that is something where we are going into in today's talk.
Okay,
So what I want you to describe little bit, uh, what is the climate scenario in India, because we can little bit talk about how the Indian weather system is in a very very
yep, yeah,
non-technical way, and then what are the implications. So if you
yeah.
can start little bit about in a very very uh, non-academic way.
Yeah. So, as we all know, India is a massive country. So, it's like it really varies if you go from the south to north or east to west in terms of the weather, synoptic weather, which is like whatever you feel at the moment, for example. So, but most of the Indians, we know monsoons because we experience this as we live in India at some part of the year. We are really looking forward to monsoons. And I come from Kerala, which is
Mhm.
like the heart of its influence. So we rely on monsoons and the rains. Basically, the monsoons, as a kid, when I was there, I always thought monsoons as the rains. It's like we relate monsoons in terms of the rain, and mostly the weather or whatever we experienced is in terms of rain. Okay, so this is what I believed. And now, when I come to the oceanography in my master's, I learned okay, it's not just the rains, there are also winds, which are the major thing. Okay, so I didn't really, it wasn't a surprise because we study these things in geography in the high school. So it was not utterly a surprise, but more details about it, how it works. So
Mm.
I think this is technical, of course, but most of us are familiar. You don't have to be a scientist to know about the monsoon. So, yeah, so if you see uh, overall, like I take a long term average starting from whenever the data is available until now, there is a pattern which is there every year. We expect the monsoons every year. But then with each year, it can change in its nature. For example, the intensity or the duration whenever it is felt. So I will mostly talk about the Kerala part because I have lived there, I have experienced the monsoon there. So we get monsoons starting from June, the summer monsoon. So we expect rain on the 1st of June. That's as early as that. And it sustains the rain until almost like September. So 4 months of rainfall, that's what we experience. And our all plans in terms of the harvest or agriculture, everybody plans for the monsoon period in certain way. So, because that's what people are used to, they didn't have any scientific knowledge or anything. Over the generations, this information has been passed on, right? So, then there is also winter monsoon, which comes by the December Jan, but that's again, it has a different characteristic. So in Kerala, how we felt is like we have thunderstorms in the afternoon, maybe it's not as intense as summer monsoon. So we have different kind of preparations for the winter monsoon in terms of agriculture or any other things which is impacted by the weather. So this is the general characteristics of weather pattern over India as felt by any general public, basically. Now, do you want me to talk about the research or what is happening now, those kind of
Yeah,
things?
yeah, yeah.
Okay, so basically, everyone has, at least in this generation, already heard about the climate change, greenhouse warming, and climate change, etc. So these things are actually manifested in terms of the change in the pattern of monsoons. For example, in Kerala, uh, I have spoken to my parents, my grandparents. None of them remember a flood in Kerala. So we are in a very good hotspot, very, very much safeguarded by the Western Ghats. So we don't have any sort of extreme weather in Kerala, most part of Kerala at least. So we get very moderate winter, very moderate summer, and the monsoon. So it's quite pleasant if you come to Kerala. But in 2018, something unexpected happened. We had this huge amount of rainfall within a week, and it flooded. And this was really unexpected in Kerala, and we were not really prepared, obviously. Nobody was prepared. No one ever got familiar with the flood. Nobody ever heard about it. Something of this sort can happen. It's not something which we really prepare for. So this really made a lot of havoc in Kerala. And since then, there had been several these kind of flooding events. So again, this is a effect which has come from multiple factors. First of all, the rainfall pattern is changing in its intensity. Next factor is like we have damaged the environment, like the Western Ghats had been exploited extensively. So whatever natural barrier is there in preventing flood or reducing the impact of flood has been removed. So,
Mhm.
and people are constructing houses uh, just at the edge of a hill, or they just dig the hill and construct a house. So, whatever impact is coming in terms of the destabilization from the flood is acted in multiple ways. Like, right, its stability already is compromised. So, when a external factor is there, it collapses. So that has been happening in the recent years, and I guess people are actually opening their eyes towards it. At least, okay, we shouldn't be doing up to this extent, sort of.
When we say about stability, what
Yeah,
we actually mean, the pattern that has been followed over a long period of time is not being followed. Uh, the timing, the intensity, how it is
yeah,
changing. So I've heard that not only the time for the monsoon onset is changing, but also there are papers that talked about the distribution of rainfall over
yes,
the entire monsoon period is also changing. So
yeah,
we are getting torrential rain over a short period of time,
yes,
and then there are
ma-
periods of pause, no rain
yeah,
whatsoever.
yeah.
So yeah, please, if you can add
yeah so
more to
yeah
that.
so so that's one aspect. So this is you can think it this way. Say like our general pattern of monsoon was starting from June to September, which spans over a four months period, right? So say like you have some certain units of rainfall that happens during that period, and because of whatever climate change impact, the whole rain, whatever is that unit, is just skewed towards a one particular month. Okay, so overall, if you take the mean over 4 months, it may be quite similar to what you have seen in the past. But how it is distributed is totally different. Instead of distributing over the 4 months period, now in the recent years, it is just skewed or focused just for the initial period. So that's the problem. So whole rain is just happening in, say, like 2 weeks' time, and then there is a dry spell. So you get the extremes, basically. So it gets flooded when it rains, and when there is no rain, you experience drought, basically, which is totally unusual for this period.
Uh, so, how this pattern or the present trends look like? Because over past few years, we have seen uh, these patterns are changing, uh,
Yeah,
and over time, we have also seen there are extreme events
yeah,
same time
yeah,
popping more frequently, like
yes,
the the cyclones in Bay of
yep,
Bengal or in Arabian
yes,
Sea, even
yeah.
some in Indian Ocean.
Yeah. So, if you ask me, again, I'm not an expert in either of these topics, but from my understanding, the main culprit or main driver for these kind of extreme events is the temperature. So, the rise in temperature is the major reason. For example, there are many studies which shows the water holding capacity of the air changes as we increase the temperature. So if you expand the air parcel because you are heating it up, it can hold more moisture. So
Mm.
when it rains, it pours, it dumps all the amount of moisture it was holding. So basically, that's one reason for a change in the distribution or pattern of the monsoon. And cyclone, as we know, cyclone is formed when there is a threshold temperature in the ocean. Okay, so to meet that threshold temperature, the atmosphere has to get warmer, right? So under the warming scenario, there are many occurrences when the threshold temperature has reached. So as a result, it triggers or it tends to initiate the formation of a cyclone. So you see more cyclones. On the other hand, these cyclones are actually maybe helping to cool down the ocean. It mixes, it induces a lot of mixing and it reduces the heating. And another factor is like the heat waves. So there are these extreme events called heat waves. So this is like basically when there is a extreme increase in the temperature from its average value that is sustained for certain number of days. So I will tell in simple like simple explanation so that it's not getting too technical. So if such conditions are sustained, it can actually fuel a cyclone which has already formed. So we have seen Amphan, for example. Its trajectory was like really puzzling, right? It was not easy to get the track of cyclones. So in India, we have a very good warning system for cyclone, and it has really been improving over the years. But Amphan or very similar kind of cyclones, which takes a tricky path, which was not expected, is mainly because it is steered by the underlying temperature, basically.
And another major part is how the Indian monsoon is changing. It's is often said is also related to the Antarctic meridional overturning circulation. So for
Yeah.
our viewers, there are ocean currents flowing within all the global ocean, and one current, or if we look at the flow, it would, if we can follow, it would start somewhere over the Australian coast, follow along, and then go around down below India. One branch would go down from Africa towards the North Atlantic, come back, and continuing this entire loop. And
Yeah.
Antarctic meridional overturning circulation is the loop that runs in the that mostly brings warmer waters from the tropical region to the northern Atlantic. That also keeps Europe and other places much warmer, and also brings about a lot of rainfalls in the tropical region. So, because you have more expertise on this field, if you can, in very general, talk about the circulation and how, but although it is happening in the North Atlantic AMOC, how our weather system or the climate system can be impacted by this, and how the monsoon can be impacted by this.
Yeah. So the Atlantic meridional overturning circulation, as you mentioned, is like a large scale circulation pattern. So if you just look at the map of the global oceans, so Atlantic Ocean is just separating in the north, at least, it is separating the United States, Canada versus the Europe and East Asia. And in the south, it is between the South America and Africa. So this is really running across the globe and over a large area,
So
basically.
it's like
So
flow of a specific type of water mass or ocean water that you
no,
talk
it's
about.
it's no. So it's like you imagine like a smaller area in the ocean will have some sort of current. Now, similarly, if you cut the ocean into smaller pieces, there will be different kind of currents which are driven by either surface winds or the oceanic properties, right? So now if you take the larger picture, link them all and just look it as a whole entire ocean, you will see that a particular current pattern just linking from the south to north, which is running. So over its path, it is driven by various factors. It's not driven by the same factors. Okay. And this is really over a very large period of time, you can see, like
Hmm.
thousands of years, for example. So it's really a slow current because it is at each box, it is a faster current or it's driven by various factors basically. So you are looking the ocean as a whole. It takes so much time to reach from one point to the other over the distances.
And the entire ocean system is connected because the
Yes.
Earth is round. It's like a
Yeah.
globe. It's
Yeah.
a
Yeah.
spherical shape.
Yeah.
So
There is
the
no
entire
physics.
ocean
Yeah.
current is connected. So in one part, if any changes happen, that change can
Yeah.
be reflected in other part.
Yes, and it is not only through the oceans, it can also be through the atmosphere. So more than ocean, it's the atmosphere which connects the globe in a faster pace, because ocean sometimes has this physical boundary in terms of the landmass, and also the water density limits its flow in a faster rate basically. But yeah, as a coupled ocean atmospheric system, it really transports messages from one point to the other. So, talking about the Atlantic meridional overturning circulation, so it is a large scale circulation pattern in the Atlantic Ocean, and it helps basically linking the lower latitudes to higher latitudes. Okay, so tropics, because of the solar sunlight exposure, we have is different kind of heat distribution. So in response to that, we have different sort of winds as well in the equatorial region or tropics, whatever we call. And as you go to the higher latitudes, either in north or southern hemisphere, the distribution of temperature and wind, everything changes. Okay, so
Mhm.
this major changes because how the sunlight is felt in the ocean. So this, sun looks at the ocean or ocean looks at the sun from different angles as you move over the latitudes, basically. So this Atlantic overturning circulation helps in redistributing the heat from the tropics to the northern pole, which is Arctic Ocean, in the northernmost part of the Atlantic Ocean. So Arctic Ocean has a large mass of glacier, which is basically the ocean ice. So similar to Antarctica. So this part of the ocean is just ice. It is supposed to be ice, but there are different stories which is emerging now. So basically, uh, say like there was no such redistribution, what would happen? So what would happen in such scenario is that at the tropics, the heat will just get accumulated. So this region will be very hot, much hotter than now. Now itself, we know when we move from Africa to France, there is a big contrast, right? But in
Mhm.
both places, we can live with certain aids. For example, in some hot places, we can use air conditioning and we can live. And whereas in cold places, we can use a room heater, but we can still survive. But in the absence of such redistribution, which is coming from either ocean or atmosphere, these places, I don't think they will be able to sustain any sort of lives there. So
Mhm.
the tropics will become too hot, and the higher latitudes will become too cold, so freezing cold, where life will be very difficult otherwise. So each of these latitudes really depend on the existence of Atlantic meridional overturning circulation. So this is just in terms of the heat I'm talking about. But there are also other major traces which are dependent on this large scale circulation pattern. For example, in the ocean, we have a huge ecosystem, fisheries, right? Fisheries, for
Mhm.
example, is a major contributor to the economy. So fishes depend on oxygen. So oxygen is higher in some part of the ocean, which gets redistributed to other part through the ocean current. So oceanic currents are a major fueling or engine which can really help to sustain the ecosystem very well. So the Atlantic meridional overturning circulation has multi-phased impacts on the lives of humans or anywhere in the globe. So it could be either through the temperature distribution. So the temperature distribution itself is important, but because of its impact on the climate or weather pattern. So it helps in regulating the global climate, basically. And
Mhm.
it also, as I mentioned, it helps in sustaining the ecosystem, which is just not local. It could be anywhere on the globe. So, for example, even in the Indian Ocean, some part of the oxygen is brought from elsewhere through this kind of circulation pattern. And this is true even for nutrients. So, if you if you want me to tell this part, this is also true for the pollutants, right? Say
Mhm.
you dump some garbage into the ocean, it doesn't stay there. It
Mhm.
just gets everywhere. It slowly and eventually it just gets distributed. So you throw something here, after a few years, you find it somewhere else. So this is
Yeah.
coming through the oceanic current. So whatever deeds we do on one part of the globe could be reflected elsewhere. So it's all coming from this kind of large scale circulation pattern. Now, I'm not really an expert on how it impacts the weather pattern in the India, but again, this is because of the global teleconnection, what we call, and this is coming through both atmospheric and oceanic impacts. Since the Atlantic meridional overturning circulation is a very large scale pattern that is connecting the northern polar region into the southernmost polar region and also other parts of the ocean. And Indian Ocean has very active link between the two. So it impacts the temperature redistribution. And it can clearly, there are many studies which is showing Indian summer monsoon is impacted by the Atlantic meridional overturning circulation.
So I think we are going to wrap up our session. If
Okay.
we want to say how the future would be looking like, and how, if we look at how to we what in which sector we need to cope with, because in Indian economy is very much driven by agriculture, and
Yeah.
agriculture still depends highly on the monsoon rainfall.
Yes.
And
Yeah.
as we are seeing, and as the recent emerging studies are indicating, the rainfall patterns are changing,
Yeah.
and that also can impact how the crop would grow over a certain
Yeah.
year.
Yeah. So I think a major solution should come from being the fact that we should be adapted by implementing the climate awareness, for example. So we should understand each part of the globe is well linked. The soil health depends on the water. Water depends on what you do in, even the aerosols or whatever is coming, impacting the global warming. So it every deed has a link to whatever you get from the soil. So we have to clearly understand or make aware into the people who are working in the field and really adapt to whatever is changing. Say like we have this kind of rainfall pattern shift. The seasonal rainfall distribution is focused or concentrated for a particular period of the season. Now, maybe store the rainwater. Rainwater harvesting is the way to overcome the drought. You should expect it can impact the next seasons or next months, few months. So you should be prepared for that. So making people prepare is the first step into getting into the adaptation, I suppose. And in Kerala, at least we have this extreme disaster management department, which became active. So, which was existing before even 2018 flood, but it became much more active after 2018.
Mhm.
So adaptation is the key, and we cannot overall stop the agriculture because of these kind of changes. So we have to really adapt and maybe try to mitigate whatever is happening. So mitigation is like reduce the impacts by realizing whatever we do has a consequence and it affects everyone. It's not just one person.
And we must reiterate preservation of
Oh
forest.
yeah,
That is
yeah.
very, very important.
Oh yeah, yeah, of course. And that it's surprisingly, if no one implements that, we learned that from every, very basic school levels, right? Erosions or whatever it is the trees which is preventing it. But we still cut the trees for whatever it is. And yeah, I think it's not just what we learn in the textbook. We have to implement it. I think that's where I would really, really stress.
And another thing also I would like to point out, in every region, there are ecosystem which is designed for that specific region,
Yeah,
because it has been
yes,
evolving over thousands and thousands of
yes,
years of
yeah,
that particular climatic pattern,
yeah, yeah,
that particular species that
yeah,
exists,
yeah,
the specific migration that happens over that region, and everything is very, very localized, and we cannot put things in a very uniform way, and we
yes,
we cannot unify things, and
yeah,
same principle cannot be applied
yeah,
everywhere.
yeah,
So the
that's well
strategies
said.
has to be concerned with the
Yeah,
local ecosystem, and
yeah,
something I strongly feel that is very much
yeah.
missing.
And that's well said. Actually, it should also be, I will just add to that point. So there is a natural ecosystem which has been evolving over decades or centuries in a region. Now, say like you just cut off all the trees and uh, introduce a new species into that
Yeah,
region, right? So it can change the entire local weather just because you bring out a
yeah.
new species
Just
into that
having carbon credit doesn't mean you're protecting
yeah,
ecosystem.
not at all. So in Kerala, there are many regions. This is experienced in my neighborhood. So we have these coconut trees in Kerala. As you go everywhere, you will see the coconut trees, and it has been there for centuries. Now some people just fancied the rubber trees. They just cut down all the coconut trees and just planted the rubber farms, and
Hmm.
it has really warmed up the region, surprisingly, or maybe expected. It is surprise for the local people why all of a sudden there is a change, and it is really,
Hmm.
really felt. And but it's too late. You cut the trees which were several decades old. Now to grow the same amount of or same number of trees, it will take another few decades, right? So without
Hmm.
having any kind of assessment, without having any kind of scientific knowledge, there should not be any actions. People should really be aware of the consequences.
Yeah. That is very well said. And with that note, I think, uh, but what to say is, we need policies that
Yeah,
that are holistic, that takes into account local ecosystem, and
yeah,
also we need policies at the global level,
yeah,
which unfortunately in present is not going as planned. But we
yeah,
are still hopeful on humanities, and we want our species to survive and show many other species, because we are
yeah,
not alone in this
yeah,
planet, and
yeah.
we don't deserve to get rid of other species from this planet.
Of
They
course,
don't deserve it, and we have no right to do that.
of course. No, no, of course. Yeah,
Yeah.
that's well said. Yeah, we have to learn to live in harmony with our nature and everything around us.
So with this, we stop the recording.